So next on the docket, thank you, Waleed, obviously, but next on the docket, we have Ada and Chris, and Aishagul, I think, is scheduled too, but there's some tech problems with that. So I think right now it's just Chris and Ada.
Yep.
And they're going to talk about the Webxr roadmap and how the W3C is approaching these problems. So yeah, I will hand it over to the very capable hands of the co-chairs of the W3C Immersive Web Community and Working Groups.
Thanks so much.
Thank you. Yeah, I'll got some slides to share, so I will get started. Great. So normally, well, ideally, Aisha would also be here, who is the other co-chair, but I'm Ada Rose Cannon, one of the co-chairs, and
I'm Chris Wilson.
I'm from Samsung, and Chris is from
Google.
And Aishagul is from Microsoft, who unfortunately is having technical difficulties.
But hopefully will be able to join us somewhere here.
Yeah, hopefully if I can waffle in for the first few slides, she'll like pop in by the time it's her bit. So yeah, here's like a very quick overview of like the timeline of how stuff has happened with the immersive web. So ignoring the Webvr bit, because that was before the working group. The working group was formed to build Webxr and to replace Webvr, and this was in the first quarter of 2018, where we did lots and lots of work for a couple of years until Q4 2019, when Webxr started to be enabled by default in browsers. This was kind of the point where it's considered like a ready-to-go drop-in replacement for Webvr. So users of the API could change their endpoint to the Webxr one and should have all the features they need to continue. In January of 2020, Webvr was deprecated. And was considered no longer supported. So hopefully now developers, especially if you're watching this, I would have hoped you would have, if you had anything working with Webvr, I hope now you've moved it across to Webxr. And then during the middle of last year, the augmented reality features started to become more available in mostly through handset browsers on mobile devices. Hopefully, we're going to see more headset Webxr-capable AR browsers soon. And as of very recently, at the beginning of this year, hand tracking became more stable and was released from not behind any flag on the Oculus Quest, which is incredibly cool. And it's been great to see people already building amazing things with this new API. And so that's kind of stuff that's happening at the moment. And Webxr has gone from strength to strength. The launch of the Quest 2 accounts for the precipitous rise around early October last year. And there was another peak around Christmas as a lot more people got those headsets. This graph is only tracking virtual reality headset use cases because it's from the CDN for the assets information, like the one that provides the controllers. So if a headset doesn't have controllers, it's probably not going to affect this graph all that much. So this isn't really accounting for handheld AR or cardboard. Speaking of cardboard devices are surprisingly still one of the most popular ways Webxr is used today. So if you are producing Webxr content, don't discount this device. It's what a lot of people are still using, and many browsers on mobile support it as one of the official Webxr like VR output formats. The majority of the content made for Webxr is 360 video content. So like the simplest thing, I know it's not like considered the most exciting field, but it is what's most popular and what people seem to be using it the most for. Also ideal for the Webxr headsets. So that's kind of cool. And I hope the people doing the 360 video content are using the new Layers API, which has started to land, because that's what is ideal for doing video content. And there is a polyfill for it in case the browser doesn't yet support it. We're also seeing increasing amounts of desktop tethered Webxr, as OpenXR is as a backend for Webxr becomes more available in browsers. We're seeing it used a lot more. It's got implementations in a bunch of browsers. Unfortunately, they're all Chromium browsers right now. So Chrome, Samsung Internet, Edge, Oculus browser, off the top of my head. But hopefully soon should see it launch in WebKit, I hope, as it is in development. So that's very exciting. So I'm hoping we'll see that soon. And here are some of a few of the experiences I'd like to highlight. These 3 experiences all won awards at the first ever Poly Awards, which was held a few months ago. So Reaction by Tower Max Fitness is a very cool looking boxing game. What You Don't Know by Jono and Mr. Doob lets you VJ in virtual reality and control the song and the visualization in real time around you. It's very cool. And Anthropometron by Dr. Keith Chan is just a fantastic example of how VR can be used for museums, and it's a really fantastic experience. So the thing which I really want us to talk about today for Webxr is kind of the features you'll have in Webxr and some of the stuff that's landed and some of the work we've been doing as a standards body over the last few years. The first thing we're going to talk about is the stuff that's available in browsers today. And then after that, we're going to talk about some of the stuff which is a lot newer. So firstly, I want to talk about just the Webxr Core. So this is where it all began. This covers mostly the virtual reality features. It was designed to be a replacement for Webvr, but made to be extensible and as future-proof as possible, so it can support the myriad of ways that Webxr can evolve into the future on all kinds of fancy new hardware that isn't even developed yet. The next module which we worked on was the augmented reality module. So this allows Webxr scenes to correctly display the virtual content on top of either a camera feed for something like a smartphone or a headset with a pass-through camera, or on top of a transparent display for something like the HoloLens. And it tells it how to render it appropriately. Next, we have Gamepad Access. So you get input from the controllers via the core Webxr API, but this only gives you 2 buttons, the grip, the squeeze, and the trigger, the select event. So Gamepad gives you access to the associated gamepad object for each controller. So this lets you access all of the buttons and the touchpad and joysticks on the controller. So this is extremely powerful access, letting you build really bespoke experiences for if you want to support a particular piece of hardware. Next, we have hit testing, so ray casting. So this lets you cast out a ray from your virtual controller into the real world and detect where it hits some real object and return this position. This lets you place virtual objects so that they appear to be correctly located in 3D space in augmented reality. So this isn't full environment scanning or anything like that. This is just single point tracking in the real world from a particular location relative to the user. Next, we have DOM overlays. So currently, this is the only way of getting DOM content into Webxr. And right now, the only implementations for it are on handheld augmented reality, and it places the DOM content over the virtual content as if it was placed full screen. So far, we need to work out what DOM overlays even means for head-mounted displays, or even if that's something that still makes sense. But that's something that's being actively thought about at the moment. Next, we have layers. So layers is really, really powerful. So it lets you, the current implementation lets you embed static images and video content in XR. So, and by video content, I mean like the video element. So you can use it for dynamic video content like streams and stuff like that. So if you have a WebRTC stream, you could hook it up using the Layers API. It gives fantastic performance improvements and a better user experience. So it's just great to use all around. So if you have this kind of content, Layers is probably the way to be doing it. In the future, Layers may be a way that we're going to be a way to display DOM content, but we don't even have an incubation for that yet. But it is something which we think is really important, and this may be an approach we take to do it. But it's still very early days for that yet. So right now, best for static images and video elements. Right, next we have hand input. So hand input gives you access to the hand tracking capabilities of whatever headset you're using, letting you both render the hand to the user so they can see their real hands, and also use this hand model to interact with the environment. I'm now going to hand over to Chris Wilson, and he's going to talk about all the stuff that's currently in development and coming in the future.
Thanks, Ada. So I'm going to cover the work that's still in development. And although the first two of these actually have early implementation shipping in Chrome, these are all incubations that may not ever land. They might take a long time to do so. There are some really hard problems in some of these, particularly around enabling features with good privacy and security protections for users. So let's go to the next slide. And what we're really asking from you is to show your interest. Like if you think these are important features, dive in, read the explainers, file issues on them, try some of these things out. We do have trial implementations of some of them under flags in various browsers. So you can really help define what the future of WebXR looks like and what use cases and scenarios really need to be filled next. Note, of course, you shouldn't ship production experiences that rely on these features. You're probably going to have to revise your code before you ship it. So next slide. The first API I wanted to mention is lighting estimation. And this is really critical for augmented reality scenarios. It's really important to estimate what the real world light sources are. So when you composite virtual objects into a scene, they look like they belong in a virtual environment. We do have a trial implementation of this. There's a pointer to it, but this is super important for augmented reality scenarios, so they look more real. Next up is depth sensing, which is the first step to kind of providing believable interactions with the real world environment, giving a continuous depth map to code so you can see where how physical objects are in the actual augmented reality scene. This lets virtual objects interact with real ones. You can have objects that sit on top of tables and roll off or something like that because you know where the objects are in reality. Combined with that is the next thing, which is anchors. And anchors, it's not always immediately obvious what the point of this is, or it wasn't to me when I first started here. It's really accounting for the fact that AR systems can provide better tracking if they know what things in the real world they're trying to anchor things to. Like in this case, anchoring to that tabletop, you can give a much better, more solid visual anchor on the tabletop coming from different AR platforms than you can if you just say, hey, position this at this XYZ position in reality. It's much better to anchor to a tabletop or a spot on the wall or some other object because the system can make that more reproducible. Next, is computer vision, and computer vision is a really broad topic. If you go look at the repository we have for this, there are at least 3 definitely big chunks to this, and one of them is raw camera access. Just kind of punting and saying, when you're running an AR system, let's just pass things through so that people can experiment with getting access to different things, detecting different things in the scene. Then there are native shape detection APIs in many of the subsystems we use, like for recognizing QR codes or text in scenes or faces. If you're walking down the street and you see a QR code in reality, that could be an interesting thing in the future in an augmented reality scene. And then, of course, other native computer vision capabilities, doing edge detection or other object detection, estimating postures, things like that. These are kind of far out there in some cases, and they definitely have some privacy concerns since you are enabling the computer to see. But this is critical to making it so that we can actually interpret the real world live. Combined with that is real-world geometry. And this is really just mapping the geometry of real-world objects, giving you not just a depth map, but actually hey, there's a plane sitting at this location. There's a wall here. Maybe giving a mesh of an object so you can see things like chairs and even potentially recognize them in the future. So this is also a super deep whole topic area. And one of the more interesting long-term efforts is geographic alignment, how you can attach objects to a real-world position, like a latitude and longitude and height, for doing a global, like using the real-world location as your coordinate system. And there are a lot of technical challenges with this, but there's also a lot of like privacy issues and security ownership issues even, like can people just arbitrarily place things on property that you own? And how that works when you start getting to sharing those locations. And then I think finally one of the big topics, and this is something that is relevant to VR scenarios as well as AR scenarios, is the current workflow to request a Webxr session requires some user gesture activation. 2D pages usually have a button that's like enter immersive mode or something like that, because we want to make sure that pages can't just take over the display without the user's permission. But sometimes you want to do in VR navigation between different VR worlds, essentially, and do that without loading a 2D page in the middle. And we're trying to figure out how we can safely do a standard mechanism to explicitly grant those sessions. Now, browsers still have the responsibility to inform users, ask for appropriate permissions outside the context of that 2D page, but this is an important scenario in the use cases that we think is interesting for the future. So with that, I want to hand back to Ada to wrap up, and we can take some questions.
Cool, thank you, Chris. So yeah, these are the next things which are highest on our priority in the standardization effort. First of all is to reach candidate recommendation for Webxr, augmented reality module, Gamepad module, and a few other really stable modules. Because taking them to candidate recommendation is what is the next big step in making it an official standard. Right now, even though these have multiple implementations, they're still not official W3C standards yet. And so they don't have the same guarantees. And so by bringing it to these next steps, we can stamp it and say, look, we're very positive these will not change unless something absolutely disastrous happens. Like it turns out to be a massive security breach in one of the features. The next features we're looking at are the ones which are bringing more web features to Webxr. So this is from the ones that Chris has recently mentioned. So these are the ones that bring DOM content into Webxr itself, and the ability to do navigation between different web pages. After all, the web has been doing navigation for about 30 years now, and it probably shouldn't be something we leave behind in Webxr. And we might have, well, not say we, but Oculus are working on an implementation for navigation between pages on the same domain. So not from like example.com to adaswebsite.com, but from adaswebsite.com/page1 to adaswebsite.com/page2, for example. So yeah, that's very cool and very exciting. And we also really want to bring the more advanced XR features to developers. After all, even though many developers are just building 360 video things, we still want to support the developers who are really pushing the envelope to build, to really see how far this technology can go. And a lot of these advanced XR features really do require some quite dangerous amounts of access to the user's information. So striking the right balance between giving power to developers but security to users is really where the challenge lies. And so we really do need your help in testing with these APIs and giving feedback. And even if you want to read through the GitHub issues and leave comments and see how stuff is going, it's always more than welcome. So thank you so much for listening. And if what we've talked about today has been like really interesting and you want to see like where the APIs are going, here's how you can take part. So firstly, just follow the GitHub repos, see what's happening, read some of the issues. There's some really interesting conversations happening there. Follow the Immersive Web Weekly newsletter, which Trevor puts together. It has a really fantastic overview of stuff that's happening in the standards efforts and in the wider XR community. It's really fantastic. And finally, if you're up to it, join the Immersive Web Working Group or the Immersive Web Community Group. Thank you so much.
Amazing. Thank you so much, both of you. Of course, we have questions. People want to know. So I'm just going to take over the screen here, and because I think I'm taking over. Okay. Yep. Here we go. Okay. So the first question, I've got 5 right now. In terms of adoption, how long did Webvr standards last? And now we want you to look into your crystal ball and tell us how do we know Webxr is going to last longer?
Webvr was around for a long time, like 4 or 5 years. Because like it came around shortly after like the DK1 did, and Brandon was tinkering with his DK1, just trying to get it working. And the reason we can guarantee that Webxr will last longer is Webvr was just put together to be something that will work using the hardware that was currently available without too much thought for building something that was future-proof. Whereas Webxr has been designed from the ground up to be future-proof and to work on newer hardware as it arrives. And Webxr has already encountered like new surprising hardware which we didn't expect, and has adapted and worked with it. So we've already seen that Webxr can be future-proof, and it's been built to last.
It's going to be around.
I think it's important.
It's going to be around for a while.
Yeah, it's important to remember too that Webvr didn't ever turn on, it was never enabled by default in Chrome, and that actually kind of helped it to for us to get rid of it quicker, I guess, because Webxr was really based on a lot of the same concepts, but with the experience of, oh wait, what wasn't future-proof when we decided to go incorporating AR into the same sessions or into the same system, and different frame refresh rates for headsets and the like. So I'm share Ada's confidence that Webxr is going to be around for a long time.
Careful, nobody holds you to that one, Ada.
Like, well,
Or-
that's where we make something candidate recommendation. That's what we're saying. Like, we're
Yes.
making that promise to the web community that we're building something that's high quality, secure, good for users, and future proof. Like, that is the promise we're making as engineers. And if we mess up that promise, we've damaged the web for years to come by having an API that web browsers need to support, and it doesn't work. So we need to make something that works because we care about the web, and we need to make something that's going to last.
And I think that's an important point, is that Webvr didn't ever go through the full process of becoming a W3C recommendation. Whereas Webxr, from the very beginning, the effort was meant to do it right, make it stable, and make it something that can last a very long time. So very different beasts, even though they sort of address some of the same root level problems.
So speaking of stability, somebody's asking if self-driving cars are going to be ported to Webxr. So we don't have to go down that rabbit hole, but maybe on a high level, do one of you want to answer that one?
Sure. I think it's an interesting question. And I would say some of the technology that is driving self-driving cars is really feeding into the same computer vision. It's doing the same object detection, not depth mapping so much as doing some of the object detection in the real world. I don't think that we'd ever do a one-to-one like trade-off there, and I would highly encourage people not to build their self-driving car system on top of Webxr at this stage, or possibly ever. But I don't want to have the liability for that.
Not for today, anyways.
Yeah,
no,
but
not for today.
I do think some of the underlying problems are similar, and I'm sure some of the underlying algorithms are being used. That's why we want to try to enable whatever native platforms can give us.
Yeah, that's really interesting. Okay, the next question, and I'm just watching our time. We have a couple more minutes, and I have a couple more questions. A very compelling use case is AR in VR, essentially enabling immersive AR mode for desktop VR use cases. For example, to use VR gadgets and other VR experiences, landscape mode versus immersive mode, if you will. What are the odds of seeing that land in the specs?
This is something which we have had brought up occasionally. It's something I personally would like to see. I would like to have the ability to run immersive AR sessions on top of immersive VR sessions. Like if you're running an already immersive VR session, you open up a new tab in your VR browser, start an immersive AR session, and then it uses the depth information from the VR scene to fill in some of the APIs. I think that would be pretty cool. And I don't think there's actually anything in the Webxr spec that disallows it. It just needs a web browser to implement it, really. So Oculus engineers, if you want to like do that.
Hopefully they're listening in. They're listening in.
And a very similar thing which I'm working on as a side project of mine is an emulator for headset augmented reality using headset virtual reality. So you build your immersive AR scene and you test it on your phone and make sure it works. And then you add this drop-in library, and then you enter immersive AR, but in a headset, and it gives you like a virtual scene, and you can hit test against this virtual scene. And so you can test headset interactions, even though you don't own a augmented reality headset, you just have a VR headset. But that's just a side project of mine, which
sounds like the multi-metaverse to me. Well, that's awesome. I think we have our next panel coming up. So I'd like to thank you, both Chris and Ada, for joining us today on this very special panel, and keep doing the great work that you're doing. We all very much appreciate it. And I think I can speak from the couple of hundred people that are watching that we all say thank you. So,
well, thanks so much.
Yeah.
Thank you so much for having us. And I'm sorry Aisha Gould's having technical issues, because she would have loved to have been here as well, as the other co-chair.
Yeah, the three of you are doing amazing work. Thank you so much.
Hey, thanks.
Thank you. Bye.